Hello everyone, my name is Rajesh Kumar and I'm your DevOps SRE DevSecOps coach. So how do you how do we how do we put the context? So here, what is Docker? Uh, Before Docker, I must tell you Docker is important. Now you should take seriously. So for that, let's understand in this way. Um, Earlier we were running the applications where let's say 10, 15 years before where we were running applications on physical server, correct? Laptop and all, correct now? Hello, am I
Yes.
audible, right? Yeah.
Yes, yes.
So, yeah. So later on, we started running apps on where? Virtual server. So virtual server, I taught you Vagrant, VirtualBox and all. So that is the one. Now we are running apps on container. Now means from last 5 years. So if you don't know the container, then it will be very difficult all of us to work on it, right? Because we are using container, we are not running application on your laptop, physical servers, virtual servers, we are not at all running. We are running in a container. So understood that this is the very important tool, all of you. Hello, hello, let's participate, guys.
Yeah, yeah, correct.
Yes.
So what is Docker? So in a simple way, don't complicate with the too many definitions. Anyone if is asking what is Docker, then simply say container management tool, that's all. No need to define much of the stuff. Container management tool, but this guy is managing container. Now what is the tools, meaning of tool here? So of course tool means a platform, you can say platform also, that will not be wrong. So tool and platform means saving cost, of course, because you are using some new tool, you are migrating from the VMs to container, and for that Docker you are using. So of course this, if it is saving a cost, then only we'll use it. Why it will, we will use, just like someone has said. Is it saving cost, saving time, and improving the quality of the work? Quality means we are all are software engineers, so quality of the work. So now you must be thinking how Docker containers can save cost. So let me put it in a very simple way. Using physical server, maybe you can run one application. Same hardware, maybe you can VM server, you can run, let's say, four VMs in the same hardware. Using a container, you are running, maybe I'm just giving you guess, 8. Same hardware, you are running more applications. So if it is running more application, of course it, you are saving a cost. How it is saving, that's a different question, but you are saving a cost, correct? Now how you are saving time? So guys, if you remember that, if you set up a physical server, one application, probably it'll take 1 day. Okay, 1 day. Virtual server, how much time it has taken? I mean, you guys have worked on it, virtual servers. How much time it has taken? 5 minutes,
10
Usually
minutes.
very
correct? 5 minutes.
fast. Mm.
And now here I'm saying 1 second. That means if you want to run Apache, 1 second, Tomcat, 1 second, MySQL, 1 second, XYZ, 1 second, Python, 1 second, Java, 1 second. That means you get a complete isolated environment in 1 second using container. How? That's a different question. So saving time. Now guys, you are saving a cost, saving a time. So the time which I am saving you with the help of containers, Docker, where you will spend. You have 8 hours of work. Earlier you were spending 3 to 4 hours only on setting up the infrastructure like VMs and stuff like that. Now I'm saving time. So where you'll spend? You will spend on the quality coding and quality testing, correct now? So you are improving the quality of software. Getting my points, all of you?
Okay.
If someone will ask you, hey, why you are wasting time in a Docker? Why you want to learn Docker? So you can say, listen, time is everything. Cost is everything. Quality is everything in today's world. So if I can save cost while running the same application, same hardware, I can run more applications, or I can save time also. Earlier, I was frustrating setting up the QA environment, dev environment in half day, one day. Now it's in matter of second. How? That's a different thing, but it's there. And then improving the quality. So these are the advantage which you have. So we should use Docker, and Docker manages the container. We should use container for that. Make sense? Make
Yes.
sense? Okay, so now next keyword which we have is management. What is management? So guys, forget about the Docker management. Talk about the VMware management. I mean the virtual box management, which I taught you. What virtual box can do? Tell me what box can do.
As a hypervisor.
Good.
Yeah. So can do what it can do. Hypervisor. It's a category, right? Virtual box is a what
Hypervisor
it can
will
do.
help me to
It
create
virtualize
virtual
the
machines.
resources. Virtualize the
Huh.
resources.
Huh. But virtual box can do what? Create a VM, start a VM, stop the VM, start the VM again, restart the VM, pause the VM, unpause the VM, and then kill the VM and remove the VM. Correct, no? These are the things you have been doing, right? You did it last week. Correct, no? Last, all of you?
Yes.
So same thing Docker will do, but not VM, container. So Docker is a management tool for containers. So Docker will create a container, start a container, stop the container, start the container, restart the container, pause the container, unpause the container, kill and remove the container. That's all. These are the things you are going to do. I'm not teaching you anything great about it. These are the commands I'm going to teach you. Okay. So now next question is, what is container then? What is container? Because I am managing the container, I am having so much of benefits from this container. So what is container? This is important questions. You should know, and you should know. So when you ask Google, they'll say it's a lightweight application runtime environment. This is the one. Lightweight application runtime environment. But we need to understand the meaning of it. What is lightweight means? Application runtime environment. What exactly that is? So we need to understand. Guys, first, in order to understand the container, we need to forget the container. First, we should ask ourselves, what are the resources we need to run one application? This question we need to ask ourselves. What are the things we need? I will not ask you question, but I'm going to answer you, and then you got to think about it. So first we need hardware. Yesterday, I mean last session, if you remember the Linux kernel, we had some discussions on it. So we need a hardware, and then we need a software. Which software? First thing in a software,
Operating system.
we kernel, right?
Well,
We need a kernel. Now, kernel. Also, kernel is a code, right? Remember that. So there's a different types of code are there. One code is namespace code. One code you can call it C groups, capability, and so on, abilities, and so on. Many other codes are there. I'm not discussing too much. So there's a namespace type also. There's a net namespace, MNT namespace, id namespace, and user namespace. These are the four important one. Few more are there. Not discussing. So now these are the types of code which we have in the kernel. What was the question? What are the resources we need to run one app? So this network code, you know what happened when you initialize, okay, in OS, okay, when you slice one network get created by default. MNT means what? You initialize one network got created. MNT means mount. Mount means root file system. Here, mount is equal to root file system. Anyone have an idea about what is a root file system?
Where the OS software get installed.
See, any operating system you see, there's a multiple file systems at the system level. One is one is one is boot file system. Then we have a root file system. We have a user file system. Then we have a application file system. Boot file system, which is nothing but a kernel. Root file system, I want to show you so you will understand this. Root means root. Have you seen this kind of file system anywhere?
Linux boxes,
Yes.
right? Unix boxes.
Yes.
Yeah, these are the Unix one, Linux one. So this is called root file system. Anything which you see in the root, this one is root, okay? That's called root file system. In Windows, we have my PC. Do we have? Yeah. So this is the root file system in Windows. My God, my Windows is filling up very badly. Okay, so here, this is the root file system. Are you understanding, all of you?
Yes.
Yeah. So what is a user file system? Let me show you. You will understand immediately. This is my account is Rajesh, okay? And here I'll go to start dot explorer. This is my user file system. Only I can see. No other users can see. Root can see it because of its privileges. I have a desktop. Let's say you get account in this laptop. You also get a desktop. I have a download. You also get a download. Make sense, guys, all of you? What is the application file system? I'll show you. So here, C drive, go to the C drive. I installed all of my software in tools location. And this is Apache JMeter. These are the files and directories, subdirectories and all. It's an application. This is for JMeter file system. Understood, all of you now?
Yes.
Yeah.
So when
Yeah.
I say mount here, one root file system get created, one C drive you can say, and then get it done. In operating system, you get it. When you start the server, laptop or something, or VM or something, you get a one network, one mount, one C drive, PID tree. PID tree, you get it one. What is a PID tree? So here, PID, namespace is a PID, but I will call it a PID tree. So people get confused between PID and PID tree. So PID means everything start with a zero. Let me tell you. So PID tree means this is a zero. and then your this is the one, okay, and this is your system D. This is running your operating system. After that, this is you, 2, and after that you run Tomcat, this become 3. Someone else has logged in, 4. This guy has run some software, 5. This is a PID ID, and this whole structure is PID tree. Let me show you. Go to the task manager in Windows. I can show you easily so you'll correlate. Go to this is one. Look at this. See, the first process is 0, and then after that 1 is not there in Windows, 2 is also gone, 4, 3, 4. This is your system D, kernel, NT kernel, you see here. And after that 144 and so on. See that here, incremented. I have not restarted this machine from last 2 days, so there's so many processes. This process is running, that's the reason you are seeing that. Some process suspended, but killed process you will not see here. Are you understanding, all of you? So this is called pit tree. Everything start with 0. Everything start from nothing, not a thing. Are you understanding, all of you? Hello?
Yeah.
I'm
Yeah.
audible? Yeah. So here, this is a PID tree. So in order to run application, you need a one PID tree created and then multiple processes. Now, in order to run one application, see here, I need one user also, minimum one user. Look at this here carefully. If you see that your Windows also, you will understand this. So here, if you see, these are the process, okay, and for the each process got the one unique PID. Look at this from the PID tray. And if you look at it very carefully, each application, these all are each app, multiple apps are there. There is a users associated with it, user like Rajesh or system user or network user. Some user is there. Do you see somewhere without user? No. You see, scroll down, see here. That means you cannot run any application without user. Correct now? Hello.
Yes.
Yeah. Yeah.
So this is the user.
Understand.
So the question was, what are the resources we need to run in one application? So in the kernel, one network should be there for accessing that application from outside. One user should be there for that application. One PID should be there, PID tree and mount. Why PID tree? Because if you see that CPU and allocations, this is a CPU and this is a RAM allocation happening from to the PID using this only. So C groups which manage the CPU and RAM allocation. CPU and RAM allocation to PID. And capability define the user permission. This user, whatever that root or non-root, user permission. So based on that, this is running. So your application is running. So these are the prerequisite. Okay. Now let me show you the one image. It will be easier for you. Docker container, enter. Look at this image. It's a good image. Uh, I don't want to get into my slide. Why? Because too much of will become a too much of content. See here. Look at the Linux kernel is here. C groups is here. Namespaces are here. Capability. Some more things are there which I don't want to discuss right now. So these are the things which is there, and that is the reason you are able to run applications. Understood now?
Yes.
Yeah.
So these are the bare minimum stuff which we need it. Am I right?
Yeah. So we got this answer. Now, guys, think about it. You need one network, one MNT, one PID, and one PID tree, and one user to run an application. That is what you get it. In OS, you get the same thing. But you know, guys, how many OS can create? These are the programs. You can initialize 10 times, it will create a 10 resources. Mind it, kernel is a program. It's not like a hardware. One CPU attached, you cannot get a two CPU like that. It's a software. You can initialize as many times, you can get it. So yes, how many times kernel can be instantiated and get the network? N number of times. N C drive you can get it. N bit tree you get it. And user anyways is allowed, and you can also create it. You can also create it. OS allow the N number of users also. So this is N anyways OS allow. But why they are not allowing this one? Because of PC concept. What is a PC stands for?
Process unit.
What is a huh?
Process unit.
Personal computing, right? So OS means Microsoft and Linux don't allow you to create multiple network, by default, multiple mount, multiple PID, because of only one reason. PC concept. PC means personal computing. What you will do with multiple C drive? Tell me. What you will do with the multiple network? What you will do the multiple PID tree? You are not going to do anything. You are a user, right? So you need only one network, one C drive, one PD for use of using compute. So yes, theoretically you can create, kernel can create n number of all these resources, but OS is not allowing it because of PC. Okay, so that is a something which you should understand. So are you okay with it? What are the resources we need to run one applications? Are you okay?
Yeah.
Okay, so let's visualize this. So guys, focus on it. This is your hardware. On top of it, you have a kernel. On top of it, you have network, one PID tree, one mount, which is C drive, and then multiple users is allowed. One user, two user, three user. This is the hardware, kernel, network, mount, PID tree, user. Are you comfortable this stuff?
Can you repeat that, please?
Hardware, kernel, and then see 111 multiple. So 111 network, mount, PID tree, and user multiple.
Okay.
Now,
Yeah, fine.
now each user will share these resources. Each user. That means every user, if you log in, you will see the same C drive. I'll put it in a very simple way. Correct now? Your laptop, 5 people will log in. They will see the same C drive because of this, because these resources are being shared. Make sense? Hello?
Yeah.
Yes.
Okay, so now next question I'm asking. This guy wants to run Apache. This guy also wants to run Apache. And this guy also wants to run Apache. So this guy has run Apache on 80 port. PID is 50, and he has written in a C Apache. To simplify, I'm using C Apache. It can be OPT Apache also in Linux. So let me ask you one question. Do you think this guy can run Apache on 80 port?
I think no should be no.
No. Why?
We have only one net.
So this guy has already used the 80 port. So this guy cannot use 80 port because it's not available, because it's the same network. 81 can be there, but that is not what we need. So yes, 80 port you cannot get it, 50 PID you cannot get it, C Apache you cannot get it because of this guy have already used it. And same case with this guy also. Understood all of you now?
Yeah.
Okay, this is a physical server. Okay, so I wanted to run Apache in this physical server, so I can run only one Apache. That's unfortunate. That is where the VM technology came. And VM technology, what they did, they said not to worry. And you know that what I'm talking about. Here you have a hardware, and here you have a operating system kernel, and on top of hypervisor. And hypervisor will allow you to create multiple VM, 1, 2, 3, and inside the VM again same thing will repeat, network mount. And so network 1, uh, uh, network 1 mount and pit tray, network 1 mount pit tray, network 1 mount pit tray. Now you see that here 1 1 1, but right now 1 2 3. Now one user one user. Now because each the VM, this is a hypervisor, like a virtual box. I taught you one of the simplest one. And here this is Linux kernel. Okay, kernel, remember that. And here you have a hardware. Now here this is a network, this is a mount, and this is a pit tree, and this is the user. So now 80 port, yes. 50 PID, yes. C Apache, yes. Same thing, yes, yes. Understood now? In the VM, isolation is happening. Understood?
Okay.
All of you?
Yep.
Yeah.
Okay, so now because of earlier I was not able to run it, but because of VM technology, which created isolation of the virtual OS, so I'm able to do that. But the problem here is, mind it, one thing I did not draw the pictures in here. Each VM you have operating system. That's the reason those is being creating. Correct? Correct now.
Yes.
Mm.
So that means if you want to run 3 applications, you need to have a 4 operating system. How? 1, 2, 3, and here also. And this is a heavy weight actually. This guy is consuming lots of CPU, lots of RAM also. Hypervisor to run hypervisor, it requires CPU and RAM. Remember that it's not only VM. Hypervisor also needs CPU, RAM, and all kind of things. So this is the virtualization world, guys. Correct? Are you okay with this image?
Yep.
So now that is where there's one guy, and his name is Solomon Hikes. Solomon Hikes. This guy started thinking about how do we reduce the cost for running application in data center. Because in data center it's not laptop, you're running in data center you are running millions of boxes. So lots of technology upgrade is happening, but he decided to avoid the wastage. His name is Solomon Hikes. So what he saw that, and it's not new thing actually, before that also many people have tried. What he saw that basically kernel namespace network, you can create n number of it. Mount, you can create n number of it. Pid, you can create n number of it. Users anyways is allowed. So why do we need multiple layer of operating system for isolation? Why? Because of Microsoft and Linux. Because they said we develop a PC for the human, not for the data center. So he changed the architecture itself. What he proposed, let me put it up in this way. Here you have hardware. On that you have a kernel. Mind it, very simple one. And then kernel you have it. And this guy is asking, okay, and when we have kernel, one default network will come. one default PID will come, and default this one PID MNT will come, and then multiple users will be there which will be sharing the resources. These resources, one user, two user. This is the default one. He said, this is the kernel, mind it. He said, hey kernel, there's a two kernel in the world which we use it, Linux kernel and Windows kernel, mind it. So he said to Linux kernel, and this is hardware, and there's some issues in my machine actually. What is that? I don't know. Okay, so this guy said, this guy asked Linux kernel, hey Linux kernel, can I create one extra, this one, what do you say, mount network and pit tree? So Linux said, yes, many people are doing it, you can create, but don't destabilize the my Linux host, people will get irritated. So it says okay. So mount is created. Linux, again this guy said, can we create one network? Linux kernel created. Can I create one pit tree? Yes. Can I create one user? Yes. Can you link, please? This user is shared user. Mind it. This user, can you link this user to this pit tree, this network, and this mount? Linux says yes. Linux to world. No problem. You can do that. Now this guy, Solomon, become greedy, and he started asking many times, many times, can you do this? Can you do this? Can you do this? And Linux to world, Linux kernel said yes, no problem. You can create, because you saw that here. You can instantiate multiple time, and then you get it these resources. Now the Solomon Hayek asked Windows initially, also Windows kernel. Microsoft denied actually. Bill Gates said no, we are very protective. We have a secret kernel which we don't want to expose it. After a few years, they realized that they made a mistake in that, and they had to open up. Anyways, so now the question is, guys, think about it. This is the user, and you have everything. So here, if you want to run Apache 80 port, can you do that? 50 PID, can you do that? C Apache, can you do that? Because 80 port, 50 PID, and C Apache, and same thing here, here. So now in this way, how many Apache you can run? 1, 2, 3, 4, 5, 6, 7, and 8, and so on. Now what is the advantage for it? Did you notice something is missing here?
Operating system.
Uh, yes. Remember that in a virtualized world, operating system is consuming so much of CPU and RAM and storage and licensing cost. Microsoft says, I need this much of money for running it. Solomon Hykes removed the operating system from the here itself. See here, only one operating system and kernel, and this all kernel is managing this runtime environment. Are you understanding, all of you?
Hmm.
So same hardware where you are not wasting for operating system, no hypervisor. See here, no hypervisor. So what Solomon Hykes developed? One very lightweight Docker. This is the Docker. And Docker, I mean, instead of this guy, Docker will ask kernel, give me, create this one. Yes. Create this one. Yes. Create this one. Yes. And attach all this to this user, this user, this user, and this user. And now what is this environment called? Any idea?
Contain.
Container. Yes. So container, you are also container. I'm also container. This container is also container, but there is a difference. When we all of us log into one laptop, we are a shared container. That means we all users are using the shared resources. But these guys are lucky. These guys are lucky. They have their own C drive, own pit tree, own network, and no operating system cost, no operating system. They all are being managed from the same kernel which is running on the host machine. So guys,
So the
this is the
so the difference between VMs and container is operating system, am I right? VM contains
correct,
operating system layer as well, whereas containers share that. Okay.
right. So here you just, let's come back to this one. In order to run any application, what you need? Hardware. Do you have a hardware in this picture? Let's figure it out, okay? So do you have hardware? Let me put it in the different. So hardware, yes. No, I'd like more thicker. Do you have a hardware? Yes. Okay. So hardware, yes. So what is the second thing? Do you have a kernel? So yes, here you have a kernel. Do you have a root file system? Here you have a root file system. Do you have a PID tree? Here you have a PID tree. Do you have a network? Here you have a network. And do you have a user? Here you have a user. See that this container has everything, correct? Correct now?
Yep.
So it can run isolated without having any dependencies outside. And that is the reason here we called it lightweight. Lightweight means it has no operating system. Application runtime environment, you understand Apache or all this thing, Python and all stuff like that. So guys, did you understand that what is container?
Yes.
Guys, this is written in Go. Okay, this is written in Go. Spelling mistake, please ignore it. Written in Go. Now they have two versions basically. One is community edition, which I'll teach you, enterprise edition. Now if you want to find out the difference between community and enterprise, look at my blog, DevOps School blog, for the future. Now this is the stuff. So by Solomon Hikes, by Solomon Hikes. Okay. So this image, now you look at it one more time. Look at this. So initially what was happening, so initially what, something problem in my machine, not sure why. It's becoming very slow. Yeah. So here, if you look at the Docker, okay, and this is the kernel. So Docker we're using initially started using this library to talk to kernel. After that they migrated to LXC. After that they migrated to libvirt. After that migrated to live container. Now they migrated to container D. Okay, mind it. This is the final one. They cannot migrate more than that. This is a container D. So if you want to talk to kernel, container D is being used and with run C combination. Remember that if anyone will ask you how the Docker is talking to the kernel, so you can say we are using container D with run C. Now container D, what is container D? So guys, container D is now standard, means it's a permanent now. So you see here container D is industry standard container runtime with da, da, da. That means anyone who wants to talk to kernel for creating a container, they need to use container D because it's become a standard for the all the community member. So managed by Linux and CNCF and many other organizations. So remember that next time this is a history, but this is a current and future also. Make sense, all of you?
Yeah, Rajesh,
Yeah.
in that case in cloud, we can use one system and multiple containers, right? Then
Yes,
it will be lost to the a cloud team, right? Instead of taking multiple hypervisors, we are using one Linux kernel and using multiple containers.
that's correct. Yeah, loss means see, you want to save cost. Remember, you want to save
Yes.
time also, right? That's we discussed morning. Where is that? I forgot. Somewhere I wrote. Somewhere I wrote. I forgot. It's here. So saving cost for running applications. You are running in a data center, right? You can't paying so much, saving time, and that means thousands of containers you want to deploy 1 second. Mind it, thousands of container in 1 second. So like that.
So, so here we'll be paying only for one hypervisor to the cloud team, right? Suppose in cloud
Yeah,
environment, if we take any kind of server or anything, right, on that particular server we can run multiple containers.
that's correct.
So we are saving a lot of money.
Yeah, that's correct. That's the reason
But
we
but
all are running this.
even without like hypervisor, we can achieve it, right?
Yeah,
Correct.
yeah, you can.
It's not mandate.
Yeah, but cloud is needed actually. It's not replacement, mind it, because what is happening? Uh, Cloud is needed. Why? Because we need a physical isolation also. So that virtual box will do that. But the thing is, instead of having the small boxes, now you have a large boxes, one large boxes around the container. So that way you can save cost and all.
Security wise also it
Okay.
is safe, right? Like no
Yeah.
data will be transferred to one container to other container.
There is a way to that. Now you have started scratching the surface. Lots of things we need to learn with this.
Okay, 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 okay.
Okay, so guys, what is the architecture for this? So this is you, human, talk to Docker client, and Docker client talk to Docker server, Docker daemon we call it, Docker D, okay, daemon. And after that, Docker daemon talk to the container D, and container D talk to the kernel, and all this thing happens. Okay, so this together we call it container D is coming in the many Linux variant, but this is when you install Docker, it will also have come along with it. So this is called Docker engine. Okay, so this is the software which I'll teach you and stuff like that. Understood, all of you?
Yes, Rajesh.
Okay, so now we have understood what is Docker, why do we need the Docker, how Docker works, what is containers, and so on. Now I'm going to next session, I'm going to do nothing but doing this one. Okay, that means I will install the Docker, create a container, start the container, stop the container, start the container, restart the container, purge, unpurge, kill, and remove. And then how to use that container, I will teach you. Okay, any questions so far?
Have any issues with our channel membership, you can drop an email to us at contact@devopschool.com, or you can also unsubscribe from channel membership anytime if you don't want to continue or did not like the video. Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Thanks for watching.